Good afternoon. My name is Jesper Gay. I'm working right now in the part one of experiment 16, and I'm going to show you how I wired the board. And this thing here, I power the board or the breadboard. Got a piece of wire here that's come from the power here going to the device here. I have a piece of wire going to do the same thing here, and I have the piece of wire that connect to that last pin here, that's the ground, and same thing for this thing here. To put the power on the board, I got a 5 volt that comes from here to connect to here, and I have this wire that connects here going to the negative sign here, which is the ground. And this thing is divided in 4 parts. So to interconnect it, I got 2 wires here. One is power, one for ground. One is for power, one for ground here. And I jump the power from here to here because I have power in this line and I need to bring power here. Same thing for the ground. I have this part of ground, but I have to jump it here, and then I have the whole thing ready to work. Okay, now let's show you. I have 2 devices here. Each device has 2 flip-flop on it. So the flip-flop or D flip-flop. What I have the flip-flop. I have the clear part of the flip-flop. Pin that my clear, they all go to a single pole switch. This is my single pole switch. And since I cannot put 4 wire in that single pole switch, I put the single pole switch right here. And then I use all that line up to it, and I can connect all the wires. I got the first flip-flop, which is this flip-flop here. Bring the wire here, connect it to one hole. Got the second flip-flop, take a wire here, go on here, connect it to the second hole. I got the third flip-flop, which is one here, bring it here to one hole, and the fourth flip-flop, take it here, bring it to a hole, and I got all my clear connect to that switch. And I have I have to connect all the pin that mark clock to a clock signal. I take the clock signal here, I bring it here, from this place here, I take a wire right there, take a wire here, I bring it to this side here, connect it to the second clock, and I take another wire here, bring it to the third one, and I take a wire here from here, bring it to the fourth one, and then I have another wire here that's go to the second one. So that's it for the clock. And so I have each output of this thing. I connect each output to a light. I got the first output, which is this white wire here, connect to the first light, and the second output, the flip-flop B, connect here, and I got the third one, connect here, flip-flop C, and then the fourth one is connect here. And then I have the output of each flip-flop connect to the input of the input D of the next flip-flop. So what I got, I have the output of this flip-flop here. That's connect to here, right here, and then I have the output of this flip-flop here, connect to the input of this one here. I have the last flip-flop, the output, but the inverse output is connected to the first flip-flop, the input D of the first flip-flop, which is this yellow wire here. That's going there. That's the only one. That's what the when they get to the last one, it's going to the first one. So that make this thing keep moving. And that's it for the wiring. Now we're going to see how this thing work. This is supposed to go count up and count down. That's the way the Johnson counter work. So we're gonna turn it on. Turn it on. Let's put the switch up. Count up, down, up, down. All right, that's it for today for this experiment, and then stay tuned for the second part of the video.